Okay, so we're looking at composition of functions. We're going to take two functions and throw them together, see what gives. Putting them together is not hard. A lot of people have had trouble in the past with the algebra to simplify it. That's where I see most of the struggles. Okay. So I'm going to give you some functions, and then we'll throw them together. So let's start with f, 3x squared minus 4, and g will make it easy on us. What's that? There are lots of ways to throw those together. We can add them. You'll probably see this notation as well. This is the same thing. All right. You just add them together. Pretty straightforward. You add like terms, so we're combining like terms here. Wait about. Oh, you hate that phrase, don't you? So what about like terms? 4 and negative 4. Okay, don't forget the negative. Yeah. Please do not forget the negative. Why are 3x squared and 4x not like terms? Yeah. Negative 4 plus 5 is, yeah. So keep adding. Subtracting is the same. I just want to show you one to make sure you pay attention to your negatives. Pay attention to your negatives. The like terms here, negative 4 minus 5. So we have to distribute this. I call that the hippity-hoppity property. Make sure you carry it through. So 3x squared and the negative 4x. Okay. Carry that negative in there, and the negative 4 minus 5 minus 9. Okay. Okay with that? All right. You get plus 1 in that thing. That's the multiplication dot. We use dots now, not x's. Please do not use an x for multiplication because I'm going to assume it's a variable x. Which you probably got through that last year. It will be written like this sometimes. All right, what's the word? That's what you're planning to do, right? Okay. Go ahead and do it on your own. And then I'll throw my work on the board and check yours. Do you have any help with it? So what did you get? 12x squared? Nope. 12x cubed. 50x squared. Minus 60x. Minus 20. Good. Alright. And then we have one more. We can write that. These ones are where it gets a little bit messy sometimes. Sometimes synthetic division comes into play. Remember that? We're not going to worry about it today. That's another few months down the road. But simplifying algebraically with fractions. I can't simplify that one, so it just stays as is. But there's one thing I have to put in there. It's a new function. See, the domain of each of these is the real numbers, right? So I have to write in where the domain is actually restricted. What can x not equal? I were, so you actually have to write that in there since it's a new function that we created to restrict it. You can add, subtract, multiply, and divide. The algebra gets a little heavier when we do composition of these functions. Remember this? Or we can also write this one. I prefer this notation, because that tells me I'm putting g inside of that. So does this one. G is inside of f, but this one's a lot easier to see. It's personal preference. Okay. So. I'm going to take g and put it inside x, right? Some yeses, do you have any notes? Put g inside of x. And for a substitute as the number. And simplify. You would remember what this means? What? Oh, yeah, you don't have to whisper. It's good. That means there are two of them. Right? Go ahead and simplify that as far as you can. We'll check your answer. Just make sure that you're good to go there. Almost there. That's correct. Good to go. We can also do G of f of x and go ahead and show that to you. See one of those. Good. Okay, you just switch them. It's actually the easier of the two. What is the domain of this function? F of g of x. We formed a new function, we have to think, did anything happen that's kind of screwed, like up here? Any ideas? Domain? Polynomial, what's the domain? Say it, please. 3. Okay, there's a few other numbers. What else can I put in here for x? Real numbers. It's a domain, so what can I put in for x? I can put in all real numbers. Let's look at one that's a little bit different. How about that nasty thing? You can see that both of these have different domain restrictions, right? This cannot be 0, right? What can that one not be? Less than 4. No. Yes. Yes, less than 4. Because that would make a negative, correct? Now, if we combine them, it's going to mess things up a little bit. Let's f of g of x. We're putting this one in there. What's the domain? Okay, x cannot be 0. Right? That one should be pretty obvious. What does this have to be? Yeah. Okay. It can be greater than or equal to 0. This whole expression. Through 0. Right? So add 4. Maybe doesn't know how to finish that one. What? Okay, that. The 1? If I multiply by 1, I get that output again. We have to move the big denominator. That way it counts. So 1 greater than or equal to 4x. And then we can divide. So we get 1/4. With these compositions, you got to kind of think through some of these domains. They get kind of screwed. And you do have to consider them. You got to consider them greatly when you get to your upper level algebra. Any questions? You can handle this on your own, okay? A little over 15 minutes or so. So 1.2,
There are a lot of numbers here. Like I said, I pick and choose. I don't just say, do them all. And I don't just say, do the odds. There you go. We'll grade it tomorrow.